Good morning, my dear student. Today I am going to discuss your topic speed. In previous class, you will discuss what is speed. I will remind you with one example that on athletics day or sports day in your school, number of children are running in a race. The student or the child which is ahead of all of them is moving with greater speed. In the same way, the student which is at the last is moving slower or running with a slow speed. The boy which is ahead, all of them will cover the distance in shorter time, and the boy which is at the last covers the same distance in a larger time. Students, in this example, it is clear that the object which is moving faster covers the distance in shorter time, and the object or child which is moving slow covers the distance in greater time. Thus, speed is the comparison of the distance covered by the object in unit time. Students, according to the definition of speed, speed is the total distance covered by the total time taken by that body. Its SI unit is meter per second. Distance is covered, total distance unit is meter, and time unit is second. Both are of smaller units. So SI unit of speed is meter per second. If distance is larger in kilometers and times in hours, the bigger unit of speed is kilometer per hour. Kilometer per hour. Okay. Now moves to the next topic, how the measurement of time happens. Students, generally our day-to-day activities are depending upon that types of clocks. By seeing that clocks, we manage our all day activities. Students, the working of that clocks is depending upon some periodic motion. Okay, one of the most well-known periodic motion is that of simple pendulum. Our forefathers noticed that many of the events are repeated after certain interval of time. I will give you certain examples that all of you will know that sun rises every day in the morning. The time between one sunrise and the next sunrise was called a day. Same way, a month was measured from one new moon to the next. In the same way, a year was fixed as the time taken by Earth to complete one revolution around the Sun. These watches plays an important role in our day-to-day life. This watches depends upon the functioning of simple pendulum. Here in that figure 13.4 you will see that a simple pendulum. This one is the string. This one is called as bob. It is made up of copper or brass. Okay, this is called bob, this is called string. When that bob is displaced from its original position, mean position, to one side, now it attains certain height. When you will release it, then it oscillates from B to O to A, from A to O, then O to B, and so on. A simple pendulum, students, consists of a small bowl made up of either brass or either copper. This metallic bulb is called bulb of the pendulum. Pendulum oscillates from position O to B, from B to back O to A, and then A to O. This to and fro motion of pendulum is periodic motion. That periodic motion is also called as oscillatory motion. When the pendulum moves from position A to position O to position B and back to position O to A, starting from A and returns to A, then one oscillation is completed. When oscillation is completed, when from one extreme position it go to another extreme position and returning back to its same position A, then one oscillation is completed. Okay, now the time taken by the pendulum to complete one oscillation is called its time period. Understand? Going from starting clock here, pendulum moves to that extreme position, returns back to that A position. How much time it takes? That is called the time period. Okay, that is called time period. You can make your own simple pendulum at home and can do that activity 13.2 by taking different time intervals. Like first one, you will take for first 5 oscillations, how much time it takes, then 10 oscillations, then 15 oscillations, then 20 oscillations, and write your observation in that table. I will show it. Then put that observations in that table. Time taken for 20 oscillations, you will take for 5 oscillations, for 10 oscillations, for 20 oscillations, for 15 oscillations, 25 oscillations, and calculate that time period. Okay, that length of the string is 100 centimeter. Okay, cotton thread you will take as an string. Do that activity in your home and record observation in that table. Okay students, tomorrow you will get next video.